Welcome to Unit 2, Chapter 4, Measurement Systems, Exercise 4-2. These are the practical exercises for this chapter. And again, the practical exercises are how you would more than likely run into these mathematical skills we're teaching you once you get into the kitchen. These are how things are going to present themselves because, unfortunately, life is not always as simple as a mathematical equation being presented to you. So you do have to do a little bit of analysis and then apply your math skills. Let's take a look at the first question. We bought a chicken and it weighed 4.5 pounds. And after we dressed it, there were 3 pounds, 2 ounces left. So we boned it, we skinned it, we cut out the gizzards and little bits of fat, and our 4.5 pound chicken was down to 3 pounds, 2 ounces. So what is the weight loss? How much is now gone? These are some of the calculations we need to make to finally get to our selling price for our menu price that we will charge our customers. So what I'm going to do is I'm going to take my 4.5 pounds and convert it to its decimal equivalent, which is 4.5. I'm going to take my 3 pounds, 2 ounces, which becomes 3.125, 2 ounces divided by 16 ounces, 0.125, so that if I remove or I subtract my 3 pounds or 3.125 pounds from my original 4.5 pounds, I'm left with 1.375 pounds. If I take that 0.375 and multiply it by 16, the amount of 16 or the amount of ounces in a pound, I get 6 ounces. So my 1.375 pounds is also equal to 1 pound 6 ounces. So the weight loss in this particular case would be 1 pound 6 ounces. Next question. If a restaurant paid a total of $27.94 for a roast of pork and it paid $1.49 per pound, what's the total weight of the roast? And they want it in pounds and ounces, rounded off to the nearest ounce. So we know we paid $27.94. We know we paid $1.49 per pound, but we have no idea the weight of the roast pork. Well, we have enough information here to figure this out. We're going to take the total cost, $27.94, and we're going to divide it by $1.49, which also represents 1 pound. So if we look at 1 pound but call it $1.49, how many $1.49 units are there in our total price of $27.94? So again, we're going to take the price we paid, $27.94, divided by the price per pound, $1.49, and we get 18.751677 pounds. And again, the reason this is pounds is because our divisor, $1.49, represents 1 pound. So we end up with this many pounds. We need to round this off to the nearest half ounce. So we have to take our 0.751677 pounds and multiply it by 16 ounces to a pound, and we get 12.026832 ounces. And if we round that off to the nearest ounce, we end up with 12 ounces. Let's put them together. 18 whole pounds and 12 ounces rounded off to the nearest ounce. Next question, a baker needed 1 pound 2 ounces of flour for cookies, 2.5 pounds of flour for a cake, and 1.25 pounds of flour for pastry. Let's find the total amount of flour the baker required, and we're going to give our answer in pounds and ounces. So let's first of all convert all of these numbers to decimals so we can use a calculator. 1 pound and 2 ounces, well, 2 divided by 16 will give us 0.125. 2.5 pounds is 2.5. 1.25 pounds is 1.25. So here's what we're adding. 1.125 pounds plus 2.5 pounds plus 1.25 pounds, and that equals 4.875 pounds. So again, we've got the no-brainer part. We've got 4 whole pounds. We're going to take the 0.875. We're going to multiply that by 16, the amount of ounces in a pound, and we're going to end up with 14 ounces. And again, the reason this is 14 ounces is because our multiplier, 16, represents the amount of ounces in a pound. If this represents ounces, then our answer represents ounces. So let's put the whole 4 pounds and 14 ounces together, and there's our final answer in pounds and ounces. The baker requires 4 pounds and 14 ounces. Our next question. If butter costs $2.89 per pound, let's calculate the cost of 25 kilograms. We can go two ways. We can either convert $2.89 per pound to its equivalent price per kilogram, or we can convert the 25 kilograms to pounds. Either way, we need to have the unit price match the units desired. Right now, our unit price is per pound, but our units desired is kilograms. We can't multiply. So let's start with the price. Let's convert the price per pound into its equivalent in kilograms. And since there are 2.2 pounds in a kilogram, we'll take the price of $2.89 and multiply it by 2.2, and that will give us $6.358, which is now the price for 1 kilogram. We take the per kilogram price, and now we can multiply it by the kilograms we want, 25 kilograms, and we get $158.95. The other way we could have gone is taken the 25 kilograms and multiplying it by 2.2, which would then give us how many pounds there are in 25 kilograms, in this case, 55 pounds. Now, our units desired, 55 pounds, can be multiplied by the unit price, $2.89 per pound, and you see we end up with the exact same price as above, $158.95. Our next question of ground allspice sells for $12.40 per kilogram. Let's calculate the cost of 1 pound to the nearest cent. Again, we're going to have to convert one to the other. So we'll go with the price. $12.40 represents the price per kilogram. If we divide the price per kilogram by the amount of pounds per kilogram, 2.2, we get a new price of 5.636363, or again, rounded off to the nearest cent, a price per kilogram, or sorry, per pound of $5.64. Number 6, our tomatoes are priced at 79 cents per pound. Your recipe calls for 3.5 kilograms of tomatoes. Let's calculate the cost, again, rounding off to the nearest cent. So we have a unit price of 79 cents per pound, but we have the units desired at 3.5 kilograms. We need to convert one to the other. So let's take the per pound price of 79 cents and multiply it by 2.2, the amount of pounds in a kilogram, and that will give us the cost of 1 kilogram, which is $1.738. Let's take that per kilogram price, multiply it by the 3.5 kilograms we need, and we get an unrounded answer of $6.083. Rounded off to the nearest cent, our final rounded answer, $6.08. Or we could have taken the 3.5 kilograms and multiplied that by 2.2, the amount of pounds in a kilogram, and find out that we have 7.7 pounds. 3.5 kilograms equals 7.7 pounds. Let's take our amount of pounds and multiply it by the cost per pound, and we still end up at the very exact same answer of $6.08. Let's take a look at a really interesting one. Milk sells at a price of $3.29 for 4 liters. Your recipe calls for 6 ounces. So let's figure out the cost of milk for this recipe, and we're going to round it off into or at the nearest cent. There's a whole bunch of ways we can go here. I like to work with the smallest unit. It just makes me feel a bit more comfortable. This is the one I'm going to show you. Again, if you're going to use a different relationship, you're more than welcome, as long as you show me all of the logic that you use to get to your final answer. So the first thing I'm going to do is I'm going to take my total cost of $3.29 and divide it by 4,000. Because there are 4,000 milliliters in 4 liters of milk. And there you see my cost per milliliter. Now that I know the cost per milliliter, I'll multiply that cost by 28.4 milliliters. That'll give me the cost of an ounce. And when I multiply that, you can see that now I have my cost per ounce. My recipe calls for 6 ounces. I'm going to multiply this by the 6 ounces that I'm looking for, and when I round it off to the nearest cent, my cost for 6 ounces of milk ends up being 14 cents. The next one, the cake that we're making calls for a 9-inch by 13-inch pan, but our pans are all sized in metric. So we're going to calculate the size of this pan in centimeters, rounding it off to the nearest centimeters. So again, it's just a matter of relationships. 9 inches by 2.54, because 2.54 centimeters equals 1 inch. So 9 inches is 22.86 centimeters. And 13 inches, again, multiplied by 2.54, the amount of inches in a centimeter, gives me 32.02 centimeters. So rounding this off to the nearest centimeters, I need a 23 by 33 centimeter pan to make this cake using the recipe that I was given. So again, it really doesn't matter if it's inches, liters, milliliters, grams, ounces, fluid ounces, pounds. As long as you know your relationships, you can get the work done.